Welcome everyone. Today is the introduction class for linear algebra that is needed for learning machine learning and artificial intelligence. So we will be studying a lot of topics around this linear algebra, and today I will talk about what is the study about linear algebra, that is study of linear equations. Then we will talk about what is manipulation of vectors, linear transformations, matrix operations, and geometric interpretations. So let's get started. Study of linear equations. Well, linear algebra is concerned with the study of linear equations and their properties. This includes systems of linear equations which involve multiple variables and equations that are linear in those variables. The goal of linear algebra is to find solutions to these equations and to understand the properties of those solutions. In the subsequent videos and subsequent lessons, we will go into much details about linear equations, which is the starting point of linear algebra. The second topic that it deals with is manipulation of vectors. Linear algebra also deals with manipulation of vectors, which are quantities that have both magnitude and direction. This includes operations such as addition, subtraction, scalar multiplication, and dot products. These operations can be used to solve different problems in physics. It can be used to solve problems in engineering, computer graphics, and of course in machine learning and artificial intelligence. The third important topic on linear algebra is linear transformations. Linear algebra also involves the study of linear transformations, which are basically functions that would map vectors to other vectors in such a way that it preserves certain properties. For example, a linear transformation might stretch or compress a vector. It might rotate the vector or reflect it across another line. Linear transformations have important applications also in computer graphics, in robotics, and of course in machine learning as well. The fourth most important property or important topic concerning linear algebra is matrix operations. Matrices are actually rectangular arrays of numbers that can be used to represent linear transformations and systems of linear equations. Linear algebra involves a manipulation of matrices to operations, again, such as addition, as inversion, as multiplication, and even determinant calculation. That is what we call determinants. So matrix and determinants. These operations are used also in a variety of applications, including data analysis, optimization, machine learning, and so on. Finally, and also very important, is the geometric interpretations of linear algebra. It has very important geometric interpretations which actually allows us to visualize the properties of vectors, matrices, and linear transformations. For example, vectors can be represented as arrows in space. Matrices can be used to stretch, rotate, or reflect geometric shapes, while linear transformations can be visualized as transformations of these shapes. These geometric interpretations are very helpful for understanding the properties of linear algebra, and as well as for solving problems in engineering, in physics, in machine learning, and so on. So with this, I will end my introductory video on linear algebra, and then we will deep dive into more important topics that we just outlined today. Thank you for your time, and please remember to subscribe and like the video.